A ball is thrown straight up and then falls back down. The graph shows the kinetic energy and the potential energy of the ball while it is in the air. The ball starts with 10 joules of kinetic energy. What is the potential energy of the ball when the kinetic energy equals 7 joules? Explain how you know. Let's take a minute to look at the picture right here. I'm going to pick up the pointer. The dashed line represents the movement of the ball and where it is. The solid line represents the amount of energy. So when the ball is just released and thrown up into the air, you can see according to the dashed line, the kinetic energy would be high, but the potential energy would be low. When the ball is at its highest point right here, the potential energy is high, but the kinetic energy is low. So let's go back to the question here. Right here, when we first release the ball starts with 10 joules of kinetic energy. As that ball is in motion, some of that kinetic energy is transformed into potential energy. According to the law of conservation of energy, energy is neither created nor destroyed. So if we started with 10 joules of energy, we will always have 10 joules of energy altogether. So if we at one point have 7 joules of potential energy, it appears that some of the energy has been lost. However, 3 of those joules are kinetic energy. 7 joules of kinetic plus 3 joules of potential energy equals 10 total joules of energy. Whoops.